接下来我们要掌声来欢迎的是 NI 的 GM Mr. Kevin Guo， 他和我们探讨的题目呢是 Accelerate EV Path to Vision Zero. Ladies and gentlemen, Mr. Kevin Guo.
拿掉口罩可以哈。Hello. All right, so the presentation today will be in English, and I'll try to speak as slow as possible so we can all have a good discussion afterwards. Okay. So my name is Kevin, and I am the general manager for NI Taiwan. And NI, as probably some of you know, is National Instruments. It was National Instruments, and then now we make it short, NI. And we have been in the industry for about 46 years doing test and measurement. So today, I'm going to talk about how test and measurement is critical for the next generation vehicles. And my topic here is accelerate EV to Vision Zero. And just so that we're on the same page, Vision Zero isn't a term that has been largely used in APAC or Taiwan. But it's a term that most of European companies, European countries, and American countries are very familiar with. Vision Zero is a vision towards two zero things. So one is zero fatality, meaning there's no death on the roads that we're commuting with. And the other meaning is, of course, zero emission. So Vision Zero, zero fatality, and zero emission really points to two things, our acceleration in EV and autonomous vehicle, which is, of course, the core of our today's discussion. So hopefully this sets the stage for the next 4 slides that I'll be discussing about. So let's move on. So what's happening in the EV industry? The acceleration of electric vehicles and autonomous driving is booming. Here are some numbers for your reference. First, by 2030, we would have over 30% of vehicles that will be sold with electric. And there will be over 50% that's level 2 autonomy and above. Let's just take a step back to where we are today. This is 2030 forecast. Where we are today is far from that. So in 2021, the amount of electric vehicles, the percentage of electric vehicles sold versus the whole everything in global is 5%. Electric vehicles started at 2010, which is like 12 years before. So it took 11 years from 2010 to 2021, from 0% to 5 percentage point. 11 years for 5 percentage point. However, there will be a mass acceleration. In the next 8 years, we will move from 5 to 30. It's not gonna take another 11 from 5 to 10, 10 to 15. That'll take forever. It's only going to take 8 years. And why is that? Well, 5% is a tipping point. And there are 4 forces, so number 4 forces that's pushing towards this acceleration. First one, obviously, is us, the consumers. We are getting more and more familiarized with electric vehicles. We are not afraid of it anymore. It's so common. When we drive on the streets, there will be electric vehicles. There will be lots of Tesla, of course. And it's relatively easy to install your own charging gun at home. And when you go to shopping malls or hotels, you often see parking space specially designed for electric vehicles with charging stations. So it's all around us now. I believe if I asked you a question that in the next 5 years, if you're to change your car, are you going to buy a combustion vehicle or electric? Some of us will be moving towards electric. It's a natural path. So we are actually changing and accelerating this adoption. Plus, it's getting cheaper and cheaper. Previously, the battery is, of course, one of the major costs of an electric vehicle, and batteries were expensive. If we compare today versus 10 years ago, battery is only 10% of the cost of 10 years ago when we started off with electric vehicles. So the cost is really driving down, which makes us adopt easier. So that's the first driving force. The second force really comes from government. All these government policies, legislations, government incentives is giving us the ability to buy electric vehicles with subsidies. Meaning if you buy a car, government will give you cash to make your investment lower. Government is trying everything they can so that we can start buying electric vehicles versus combustion. And that's really for a greener Earth, right? So the emission, the zero emission, this is something that many European countries are really going towards. So the incentive that the government is placing on the electric vehicle really boosts the adoption. And not just incentive, on the contrary, the government is sometimes placing penalties for high emission cars. So if you have old cars, you're getting penalized. And car makers making high emission cars, which pollutes the air, are getting taxed for that. So that also comes to our third driving force. The third driving force is car makers, OEM car makers. Many car makers, all the big names, BMWs, Porsche, Maserati, they're all coming out with electric vehicles. BMW states that by 2030, 50% of their models, new models, will be EV cars. And that is pushing us towards this path as well. And why are they doing this? Well, of course, government is giving them a lot of good incentives for them to be inventing better and greener cars. Of course, for them, it's also competitive advantage towards the competitors. So many cars that you previously thought would not be electric becomes more and more electric. I think one of the best example is Porsche. I mean, Porsche has been in the market for sport cars, right? Sports car and electric vehicle, this is not happening. Like sport car, you need to hear that acceleration, that boom, boom, right? But even Porsche is coming out with electric cars. So this is really showing how the OEM car makers are going towards that direction. Finally, the fourth pushing factor is corporate. We all work in corporate. Corporate have corporate cars. Actually, a large percentage of cars that's being bought are from companies for company use. And it makes a lot of sense to boost the branding of your company if you buy an electric vehicle. It's just natural. So the companies are pushing towards that as well. So all these four factors is the tipping point that we're seeing today, which will boost our sales revenue or the volume that's being sold in comparison to 5% today to 30% by 2030. Below here it states about 50% L2 autonomy. I think this is a given. L2 autonomy basically is just ADAS. It's not even autonomous driving. It's just driver assistant. It's ADAS. I think most of the car that we bought today is ADAS enabled. Your like parking assistant, your highway driving, keeping you at the constant cruise speed. I mean, that's given. So I think the 50%, that's for sure. And I assume there'll be a certain level of L3. Although the technical advancement required for L2 and L3 is significantly higher, because at L3 you're basically able to take your hands off and then not look at the road, do whatever you want, and drive by itself. I think there's a big technology gap where a lot of tech giants are playing into this game. The OEM car makers, again, the BMW, the Porsche, we're at the Benz. It's moving toward from level 1, level 2, level 3, level 4, level 5. It's a natural progression. But there's a lot of tech giants that will just jump straight into level 4 and skipping level 1, 2, and 3. And I think it's because they're not car makers, right? They're the tech giants. We're talking like Alphabet, right? They're just jumping straight in because that's where they beat their competition. That's where they get into the vehicle market without having to go through all this trouble, and that's where the competitive edge is. So I think For the autonomous driving, there'll be a mix of what's happening. It's harder to predict versus the EV percentage. All right, so what does that mean in terms of the challenges that we all will be facing? There'll be abundant challenges in how we test, and that's actually my session today is about test, because MIH is a test measuring company, but I have to talk about how the trend is so that we understand what's the challenges that we'll face in testing. So if you look at the left-hand side here, traditional cars are pretty simple in terms of their supply chain. A car is a system of a lot of different systems, okay? And each of the little systems or component or modules is being made by tier 1 suppliers that has long history of collaboration with the OEM car maker. And these modules are made by components which has histories of relationships with the module maker. So the way you test them, it's simple. You have specific specs that you have to match, and that's it. That has been like this for years and years. That is how currently lots of cars are made. But when we switched to ADAS, when we switched to electric vehicle, it's different. Every company is on the bleeding edge of technology. We are like rushing towards faster time to market. And components that we're using today may not be the component that we want to use next year, because there are other companies who can do this better, and you just swap. And the performance of a car is not gated by the specs anymore. The performance of the car is gated by the software that's built into all these modules, interconnecting them together. The performance is become software-based. It's a mix of virtual reality and physical devices. And that complicates things. So how do we tackle these challenges? Well, we tackle them in a few different ways. And here I will show you how we feel, and I feels, this problem can be tackled. First, in the design phase, companies designing new technologies for EV needs to have a solution that's a lot faster for you to innovate, so that we can shorten your time to market. This solution or this testing device needs to be flexible enough so that you're able to use the same tester or testing device for your next generation of product, which may come just 6 months from now, and you keep on reiterating and improving. It needs to be very flexible. This is so different than the traditional car makers, where you buy a product test system and you can use it for 5 years. It's impossible. For here, every 6 months, every few months, you have a new iteration and you have to change. So you need to be looking out for a test solution that's flexible enough for you to achieve this. Secondly, you need to have something that will lower your cost in production or end-of-the-line test. I mean, this is a very competitive market. But if you want to lower costs, however, we're talking about vehicles, you need to be safe, right? So you cannot really, skip testing just to lower cost. So lowering cost becomes a fine balance between your test coverage, your throughput, your footprint, and how you're able to test it faster. So the ability to have a test system that enable you to rapidly design and lower your production cost becomes your competitive advantage in a bleeding market where technology just keep on advancing at a faster pace. And I does this with 3 different factors. One, you need to have a test solution that has connected data. I can talk about this forever, but basically, connected data is a way for you to enable having data insight on large data. So basically, if you're able to have a test solution that's able to map from your design to production with the same set of data that you can use to improve your design throughout the phase, because you're having the same platform, same data chain, then you're able to improve your device a lot faster and reiterate a lot faster than other companies who may have different siloed solutions throughout their design phase. Second, you need to be able to reuse your test assets, meaning do not buy testers over and over again just because you have a different component that you want to test, because we're always advancing in technology. So of course, hardware leverage. And the third one will be software that you're able to interoperate between design and manufacturing. So the whole core here is really having a way to tie your design to production using a single hardware platform and a software platform. That will give you a advantage in your design. Now, where does NI plays a role in this design to production? What can we do? So we divided this challenge into 3 different sections, from electrifying to autonomous and to ECU. So in the electrifying phase, basically a lot of tests and are required for batteries. So ranging from battery cells to modules and packs. Definitely you need to have the ability to do tests faster and able to produce them faster. So battery tests, definitely one of them. Traction inverters is also very important, where you have the need for signal hill and power hill, of course. I think we're partnering with DMV as well, who is on, who should have demo there, right? DMV for power hill. And of course, all these converters, so AC to DC, 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 all your OBCs and DC, DC, and your charging devices. So all of this are required for the electric portion of your design. And I have solutions in that, but we're partnering with many different partners. One thing that's special about NI is we don't do this alone. We partner with all of you. You may be someone who's very specialized in the industry in some specific component, and we'll partner with you to come up with a solution that's suitable for everybody's use. For ADAS, that'll be another, a totally different set of tools that's needed, where our ability or our value is to enable you to capture data and virtualize the data so you can use the data in your labs to improve your ADAS algorithm, instead of going out on the street and test out your new software design. So this is really about going out and have a recording system that you're able to record all these sensors, your LiDAR, your radar, your camera, right, your ultrasonic sensors, able to capture them, able to store them, log them, and then back in your office, you're able to replay them and then inject faults, inject virtual reality into it so that you're able to test your ADAS device a lot faster than going out on the street. And the technology really is with a lot of data streaming, capturing, and then time synchronizing them. And that's what NI provides together with our partners, of course. And on the very right-hand side would be the ECU testing, because ECU becomes very critical in a electric vehicle. And we have solutions for that as well. All right, and I see someone telling me that I am over time, although I only have like 5 slides, but I'm talking too much. So let me speed this up. One advantage that we really want to highlight is the product life cycle, meaning that, again, the data that's from design to production, that's really critical for you to have insight on how your design is. So product life cycle, definitely something that you want to watch out for. And in the end, what can we provide? NI provides you with the ability to shorten your time to market, right, to increase your yield, of course, and not at the sacrifice of quality, right? Improving quality and then lower your cost. And we work with your customers to understand their needs. And of course, the safety that's absolutely required. And in the end, we're here to partner with you on the engineering portion. We have a lot of engineers. We have a lot of partners that can work together with you to engineer for EV and ADAS. And we hope with that, we can enable you to engineer ambitiously for the future of Vision Zero. Again, it means zero fatality and zero emission. And that ends my keynote speech today, and I hope that you have a fruitful learning day. Thank you.
All right, thank you very much, Mr. Kevin Guo. Love that punchline. Engineer ambitiously for Vision Zero. Zero fatality and zero emission. Yes, that is what we're after.